right? Okay, cool. So, okay. So
You should slowly start back from the start then, so I could always review this when I get lost.
yeah, absolutely, absolutely. You know what? I will repeat the first few questions. Okay. Assume that you don't know the answers and you think and you give me the answer. Okay. So what is the name of this operating system, IBM? I will not gonna call you egoistic if you say I. It's a lowercase I. There is no ego about that I, right? So IBM I. Which other operating systems can you run on this hardware machine?
AIX and Linux.
And Linux. Okay, what is the name of this hardware machine? Power system. Power system. Okay. This architecture, the architecture of the operating system, I will jump between chapters 1, 2, 3. Okay, so I'll let you know, go chapter by chapter. The architecture of the operating system is called
Object-based.
The architecture. Let's see if you can get it. I'm making some gestures.
Layer-based.
Thank you. Layered-based operating system. Okay, that was chapter number 3, right? So we have the IBM iOS at the top. Who do we have after? What layer is after IBM iOS?
The Timmy, TIMI.
TIMI. Very good. Timmy is fine. With me, it's fine. Okay, I don't know about IBM. Next one is
it Slick?
Slick. Yeah. Timmy is Slick, right? Timmy is Slick. So when Timmy is Slick, who does the Slick talk to?
Hypervisor.
Hypervisor, right? Because he's so hyper, he's in coffee, so he can talk to who? The last layer.
Risk hardware.
Right. You got to risk. You have to take risk when you're that hyper, especially when Timmy is being slick, right? So IBM iOS, TIMI, SLIC, hypervisor, and you have your hardware, which is RISC-64. So the storage on this platform, what do you call this storage? There's a word for it. It's
Library?
Single level.
Single level. Yeah, single level. Yeah, single level storage, right? So single level storage, everything is at the hardware level. You don't understand what it is. Objects. It's an object-based operating system, as some of you already answered that. These objects are items which have name and fill in the blanks and
Attributes.
and take up space. Okay, items that have names and take up space are objects. You interact with this operating system with the help of an object. Now, everything is an object, but are system values objects?
No.
No. Are parameters objects?
No.
No. They are just defining the command.
Yeah.
Now, what is the name of the language in which we write the commands for this operating system?
CL.
CL, control language, which can be used to write individual commands, and you can also write programs, which are called the control language programs. Objects on this operating system are interacted with via commands, right? These commands will or will not run on an object. How does that decision take place? That this command will run on the object or not?
It is entered correctly.
Even if it's syntactically correct. That's right on the beginning.
Permission based.
Say it again?
Permission based.
No.
Value.
No, it's right on the first page of chapter where it talks about the layered, right before the layered.
Oh.
Talks about, there is a diagram at the beginning of chapter 3 on the second page, which, so did somebody say, who said something last time? Did somebody said something?
Value.
No, not
Simple
value.
object name?
No, not names don't matter.
Does it have to be the right object type?
Very good, Alex. It's object type. Okay, so when you run a command on an object, based on the type, the system decides if an object can take this command or not. So for example, if it's not a program, it will not take a call command, C-A-L-L. Call command is only designed for program objects. So if it's an RPG program, a Java program, any kind of a program, you can only call with a call command, okay? What command do we use to call a menu?
Go.
Go command, right, exactly. All commands are a combination of verb, subject, and
Modifier.
modifier, except for how many commands?
2.
Two commands. What are they?
Go and call.
Go
There's-
call.
That's it.
All go.
Go and call. Okay. Don't tell me who to call. I'll just go and call. Okay. So the verb is 3 letters long. Noun or subject or modifier could be 1, 2, or 3 letters long. Okay. For example, copy file. What is the command for copy file? In short, what is the actual command?
CPYF.
CPYF, right? So CPY is the verb and F is the subject, only 1 letter long. Okay. If I would like to display my library list, what should be my command?
DSP LIBL.
Very good. So DSP.
Got me on the test. Ah,
DSP is for display, LIB is for library, and L is a modifier for list. Okay.
Yeah, I hated that on the quiz too, by the way.
yep, I got it wrong. So I got 80%.
30 is better than my 40. For misreading.
At
The
least,
commands are actually really good at.
at least none of you wrote me any nasty emails. I've received some nasty emails in the past.
I actually read the question wrong. And that's why I answered it wrong. A couple of them. I was like, why did I do that?
That caught me off guard.
Add library list entry. What's the command?
ADDLIBL.
E. Very good. Okay, list entry, right. Okay. How do you change the current library?
CHGCURLIB.
Correct. Change current library, okay? Of course, you took the quiz, I know, but so change current library 333. It will never have 343 or 334. It'll be only 333 maximum. Okay. Now, let's say if I would like to edit my library list, what command would I make? What would I call?
EDTLIBL.
EDTLIBLE, edit library list entry, right? Now, I also gave you a document last week where I marked down the page numbers on these where these commands are. By the way, all of you gave me the wrong answer. I said edit library list. It's not edit library list entry.
I said I didn't put the E in at the end.
No, okay, you didn't. Somebody did. So it's EDTLIBL. There's no E in there. Okay. So E is only in there in the add library list entry. Okay. So how many types of screens?
4.
4. What are they?
You got menu, you got, oh God.
List, prompt.
I didn't know that there was a menu called, oh God.
Oh God, that was me. I had it in my head and my mind went blank.
That was, oh, you mean help. Oh,
If I could have F1 in my head, I would have done it.
okay, help. Okay, so we got the menu, we got the help, and we got the prompt, and we got the
List.
list. Okay. If I would like to go to a prompt, I type a command. How do I get to a prompt? Which function?
F4.
F4. Okay, cool.
F4.
If I change my mind and I want to come out of the command,
F3.
F3. Okay. If I am sitting inside my prompt where I can make an entry and I'm not sure what to do, what do I do?
F1.
Press F1. If I need to get more information after I press F1,
those?
F2.
F2, extended help, right? Okay, if I'm sitting on F2 help and I press F3, where will I end up?
Back at F1?
Back to the
Or all the way
prompt,
back?
back to the
Back to
prompt, right?
Okay.
If I'm on F2 and I hit F12, where will I end up?
Oh, that's
F1.
right, the main menu,
F1,
right?
F1,
Oh, really?
okay?
I gotta
Yes.
mess with that more.
So now when I press F3, I'm out of help and I'm on the prompt. Okay, now I'm outside of the prompt. Okay. Any utility, how do I start the utility? Give me the syntax. Starting a utility.
Does this have to do with spooling?
No, it's utility is an application that has a name, but there is a way to start an application. And there is an example in that table I shared with you last time, which was basically page 45, chapter 2, second page of chapter 2. In
Figure.
STR?
STR, very good. STR followed by the name of the utility. So
I had
table
finished coughing, sorry.
2.1, page 45, right? So STR followed by the name of the utility. Okay?
Yep.
Anytime you know the name of the utility, if this utility's name is PDM, the command to start will be strpdm.
Yep.
If the name of the utility is SQL, strsql. That's how it will go. Okay. How can you tell if you're looking at a screen that looks like a menu that it is not a menu?
Huh.
If it doesn't have the header.
Very good. The header will be missing a few things. If it is not a menu, it won't have a menu ID. It probably may only have a description in the middle. Won't have a system name, won't have a menu ID. So in a typical menu, if you go back to chapter 1, for example, where the menus are being talked about, I can tell you the page number also. Page number 11. How many parts does a menu has?
4.
4 parts, okay? The top part is the header. The header has the menu ID in the top left corner, description in the middle, and the system name in the top right corner. What do we have in the middle?
New description.
In the middle, no, right after the header, right in the middle of the screen. Options like numbered options. And then you have at the bottom the prompt and
Function keys.
function keys. Very good. How do you press the function keys over F12?
Shift.
Shift. You make a combination with a shift. Very good. Okay. Now, okay, let's see. You are to create a library. How do you create a library? What command?
CRT.
lib. Okay. All the menu names for commands, what are the first 3 letters that they all have?
CMD.
CMD, very good. It doesn't matter they're by subject or by verb. The first 3 letters for the menu name will be CMD. Okay. What will be the name of the menu for all the library commands?
LIB.
CMD lib,
Yes.
right? CMD lib, that'll be the name. Okay. What will be, and library is a subject or a noun. What will be the name of the library, name of the menu for all the create commands?
CMD CRT.
Very good. What will be the name of the menu for user commands?
CMD USR?
Very good. Okay, that's how you go it. Okay, if you want to look at all the verbs, how can you go to that menu?
That's not me.
CMD VRB.
No, it's just
Go verb.
VRB. It's just go verb. That's it.
Yeah.
Go verb. Okay. If you want to see all the subjects,
O subject.
go subject. Very good. If you want to see the highest hierarchy where all these command menus are defined, what is the name of that menu?
The hell?
No. The name of the menu. Which is the top level menu for everybody.
Is it just go?
No, Go, it has to have a name. Menu has to have a name. It cannot be just Go. Let me tell you the page number. We're going to make your life a little bit easier. Page 57.
Major?
Page 57, yes, major, correct. And for the Kindle people, it's figure 2.12. Figure 2.12. Go major. Around that place, figure 2.12 around that place, not exactly.
Yeah, that's fine. Just give me the figure. Will give me the general area. I'll be able to figure it out from there.
Okay, cool, awesome. So the Go major will be able to let you go that far. Okay. How many libraries can you have maximum total in your user library list?
15.
250, okay. And how many production libraries can you have maximum?
What?
How many production libraries can you have? Maximum number of production libraries?
3, I think.
2.
2. Okay, it could be 0, 1, or 2. How many system libraries can you have maximum?
15.
15. Okay, and that information is on page 60, table 2.3. Page 60, table 2.3. If a library name starts with the letter Q, what does that tell you?
System?
It's a system library.
It's a system library, so you should refrain from starting your library names that start with the letter Q. Awesome. Where are all the objects placed?
Hmm.
In the libraries?
In the libraries. Very good. Simple, right? What is a qualified name?
A name that includes the library.
Very good. The name of the object that includes the library name. Otherwise, it's an unqualified name. When you look for an object with an unqualified name, how does the search happens?
Top to bottom.
From top to bottom. As you can, there's a page in the book, right, that talks about that somewhere in chapter 3. Let's see. That would be page 86, figure 3.3. Figure 3.3, page 86.
A weird noise.
Loud mechanical keyboard.
Mechanical keyboard. Okay, cool, no problem. So it always starts from top to bottom, system, then current, then user. How many current libraries can you have? One and only one. Okay. Now, when you provide a qualified name search, what happens? What's the first step when you provide a qualified name search? There is an entire flow chart in the book, right? That talks about that. Page number 97. That will be figure 3.14.
Explicit qualified name. Yes or
If it
no?
is, then it checks your authority on the library, right? Then it makes sure that it has found the object with the proper type that you want to run the command on. If yes, then it checks to see if you are even authorized to use this object. If yes, then it runs the command. So many steps it goes through before you can access the command. Okay. If you were to store an object, that will be page number 100, figure 3.16. Page 100, figure 3.16. When you're trying to store an object, it first checks to see if it is getting stored with a qualified name. If yes, Then it checks to see if you are even authorized in that library. If it is not with a qualified name, then it directly puts it in the current library. If it could not locate a current library, then it goes in the QGPL. What is a spool file?
I don't know. Paul.
So again,
Output,
it's a staging area where the output is placed, correct? Okay, and this spool file is in which queue? What is the name of the queue?
Output queue.
Output queue, very good, okay. Spool file, if it needs to go to the printer from the output queue, who picks it up? Who picks them up?
Print writer.
Print writer, okay? All of that detail on page number 102, figure 3.18. Page 102, figure 3.18. You grab the spool file from the output queue, put it to the printer, print writer, that writes it on the printer, okay? Now, every time you submit a job to the operating system, the job runs inside a what?
Subsystem.
Subsystem, very good, which is just an environment in which things are placed. Okay, now go back to page 101, figure 3.17, and go over that picture again. Okay, what is the definition of the word parameter? Parameter.
Attribute.
Yeah, the additional values for the command. Page number 44. Right before table 2.1, it gives you in a graphical format the command name space parameter. Okay. CL commands may have required parameters or optional parameters. And parameters are additional values that you provide with the command. Do parameters have to be in certain order?
yes.
Yes, okay. What are the two different ways in which you can set up the order?
Keyword and crap. No, I know it's not crap, but I mean, dang it. Keyword notation and
Positional notation.
Yes,
positional. That's the other one.
yes, keyword and positional, okay. What is the biggest disadvantage of positional?
The parameters have to be in the correct order.
Otherwise, things will not work, okay? Just so that you can see as an example, page number 53, right after figure 2.6, you can see right at the beginning of page 53, two lines. The first line is create library, payroll, test. The second line is create library, test, payroll. The second line will be an error because it doesn't understand what you mean. If it to the system, it assumes that asterisk test is the name of the library, and you can't have asterisks in the names, so it will just yell back and say error. Okay, on the contrary to that, if you turn to page 48, right above figure 2.2, you may see a similar example, but with keywords outside the parentheses. Figure 2.2, right above that. Bless you, Felton.
Thank you.
No problem. Okay, how do you know if it's a system value? How do you know it's a system value?
If it has an asterisk,
Exactly. If it has an asterisk, that's about it. Okay. So for example, if you are looking at figure 2.3 on page 49, look at the way prod and blank are written. On page 49, figure 2.3, the prod and blank, they both have asterisks right before them. That shows that they are system values. Okay. If I'm creating a library using positional notation, and I only give the library name on the command prompt, I say CRT-LIB space, and I give the library name, then what happens? Does it error that? Because I
Does that
didn't give
prompt
the
you for
type?
more information?
it takes you to the correct create library with a prompt to create an.
No, I'm providing the name. I wrote CRT-LIB space, and I gave some name to the library and hit enter. What happens?
Doesn't it create a production library automatically?
Very good, Samuel. It defaults to production library. It doesn't errors out. Okay. Okay. One more thing I want to show you guys. Okay, page 57, table 2.2. Just so that you can also look at some examples of menu names, irrespective of verb or noun, they all start with CMD. Page 57, table 2.2. How many user classes do we have on this operating system? Chapter 1.
Is that 4?
4. Chapter 1, page 7.
Casual user, programmer, operator, and security officer.
Very good. Okay. So user classes are 4, page 7, all the way towards the bottom under user profile, first bullet point. Casual user, programmer, operator, or security officer. Okay, security officer is the top level guy, is the admin. Okay. When you first log in to the IBM, what are the first 4 letters of all of your IDs?
ITPA.
ITPA, followed by your 3 digits, right? Okay.
Yep.
So when you log into V2 Cloud, do you use your Blackboard ID or IBM ID?
Blackboard.
Blackboard, okay? IBM ID is only needed to access the IBM server. If you're going to V2 Cloud to do your Visual Studio homework for Wendy or Alan, you do not need IBM ID. Okay, If you want to just use PowerPoint because you don't have PowerPoint on the computer, you're sitting on, you open the browser, you go to V2 Cloud and you use PowerPoint on the V2 Cloud. You don't need IBM ID. You just can log in with Blackboard username and password. The only time you will need the IBM ID is if you try to log into the IBM server. Doesn't matter what tool you use. You use 5250, you use Run SQL Script, you use RDI, doesn't matter. As long as you are not connecting to green screen or any of the IBM tools, all you need is your Blackboard ID and password to get to V2 Cloud. Okay. Now V2 Cloud needs to be renewed every semester. So what happens is at the beginning of the semester, based on the people enrolled in the classes, a couple days before the start of the semester, we send in that list to the tech, who then authorizes people to access V2 Cloud. Sometimes when people register a little bit late or are late entering into the class, they never made it to that first list. So that's why you don't see V2 Cloud when you log in. And then, you know, and then we have to place a second set of requests, which sometimes could take a day or 2 or 3 days, depending on how busy they get at the start of the semester, because everybody is placing their requests at the same time. Sometimes you get lucky because you are in multiple classes and maybe the other instructor sent in the request for you before I did, and you are able to access the V2 Cloud. So, but yeah, either one of the two things. Yeah. So when you first log in to the IBM through, what is the name of that green screen environment?
5250.
5250 emulator. And you enter your username and password, and if it is unsuccessful, after how many attempts it disables your account?
3.
3 attempts. Okay. Now when you log in after, let's say, 1 unsuccessful attempt, the next time you logged in, okay, so where does it take you?
Sign on screen.
Say it again.
Sign on screen.
No, after sign on screen. After you successfully sign on.
Oh, main menu?
No.
Last time you
Are you
logged in.
talking about the last time you logged in?
What is that thingy? The answer is on page number 7, by the way.
Sign on information.
Second last,
Initial program.
yep, second last bullet point at the bottom of page 7, initial program, which is programmed so that it tells you how many unsuccessful attempts you have made also, besides when you last sign on.
Ah,
Okay. So once you hit the count of 2 there, the next time you made will automatically be disabled. Okay. Then after that, you see your initial menu, which is main menu for you guys. Okay, awesome. What is the purpose of the function key F5?
refresh,
Refresh. F9,
retrieve.
retrieve. What does that mean?
Retrieves the last
Retrieve
commands
the
you
last
put in.
command. Yeah,
Very good. It just takes you through the history of the commands that you typed in that session. Okay. Now, let me ask you this question. I typed CRT-LIB and I pressed F4. It took me to the prompt, right, where I can fill in the library name. And I changed my mind and I hit F3 and I exit out of there. Okay. If I now press F9, will it give me CRT-LIB? Yes or no?
Yes.
No, because I
Understood.
never completed the command. Okay. The command has to be completed, even if it's an error, for it to be recorded in history. If I type the command and cancel it in the middle, it doesn't record it. Okay. Now, if I create a library, successfully I create a library, and I have to change the library name, I can press F9 and then how can I go to a certain location where I can start changing the names? Can I click with the mouse?
No.
So what do I do?
Man.
Arrow keys.
My notes.
Arrow
EDT,
keys.
LIBL.
I use arrow keys to go to that location where I want to start making changes, and I start making changes. Okay, now let's say, let me put something in the chat. Let's say the name of my library was SAD 101. You know, it's not very happy library, right? I want to make it a happy library. So I type F9. So that gave me this line, okay? It gave me that line. I want to add one A after S. So I take my insertion point right at that spot. And then what do I do?
Press insert.
Press insert. If I don't, what happens?
You overwrite.
I overwrite, exactly. So insert key will change your cursor from a blinking cursor to a block cursor. And then you can insert a letter, and then you can press the insert key again to bring it back to the original mode. And then you can hit enter. Exactly. So you will type CRT, LIB, you know, okay. Okay. I'm not kidding. That's what my name means. Okay, so are commands case sensitive?
No.
No. Are parameters case sensitive? No. What
No, I
is
don't
case
think so.
sensitive? Is there anything that's case sensitive?
No, right? There's
So
nothing that's
far,
case
right?
sensitive.
Only the data of type text.
Oh, okay, okay.
Okay, only the text data is case sensitive. Otherwise, nothing is case sensitive. Okay. Okay. What number do I press on the main menu to sign out?
90.
90. Very good. Okay. Good ears though, right? You know, they just never made the jacket pockets big enough to fit my Walkman. I don't know why. What was the deal? Everybody was using Walkman, but they just could not make large enough pockets. It was always sticking outside.
Mine did,
had
and I was
belt
like
lips.
12.
Yeah. You're supposed to hook them on your belt.
Yeah, probably. You know, yeah, they have those bell cookers, right? But then
Yep.
they would constantly unhook because people were wearing strange clothes back in 90s.
Yes, we do.
It was like funny days, right? People were, I remember late 90s, early 2000, people were so professional if they had a stylus with those big Blackberries on them. Like, oh, you're a busy guy, right?
Or got a pager for that matter.
Oh, the pagers, right?
Yeah.
The pagers. You know, when I was in high school, a friend of mine had a pager. So with the pager, it beeps. So what we would do is, you know, stupid stuff. We would go in an aisle and we would turn on the pager, and everybody's protecting their pagers.
The cool kids had pagers.
Oh my God, we were like so stupid, right? But it's fun. It's fun. I would literally go to Home Depot on the days when nobody would be like around, and I would grab a salesperson, start asking stupid questions because I was bored at home and had nothing else to do. I said, okay, how long will this fit? Are you sure? Are you sure it's not going to fall on my head? Oh, it doesn't look that strong though. Is it sturdy?
Oh man, didn't you have an Atari or something to play?
You know, being 18, 19-year-old kid, you do stupid things. You know, you didn't have internet or other things back then. So anyway, you know, okay. We had our own ways of having fun.
Oh, yeah.
Okay, so any questions left? Chris is like, are you kidding? No, good, right? Don't ask me more. Okay, sure. So with that, let me start chapter number 5. So let's go to units and let's go to the unit 4. I will be sharing my screen. Just give me 1 minute. Okay. So here, as you can see, our main focus over here is chapters 5 and 6. Our main focus is to learn about DDS. We'll be learning about source physical files. We'll be learning about physical file members. We'll be learning about SCU, PDM, and if we have time, DFU. We'll see how far we can go, okay? The list is a little bit longer. There are like not too many topics. It's just like they're all very connected topics. So that's why I listed them. You cannot complete the subject without talking about all of them, okay? With this, it reminded me to ask you one more question, and that is, you store your objects in libraries, right? How does a library knows what object it has? Or when you look for an object in a library, how does it tracks how to go and look for it?
Permanent
The
physical.
bottom.
Say that again.
Permanent physical address, like a pointer.
It has a
To the
pointer
address.
for permanent virtual address. Okay, because operating system doesn't have access to the physical machine because of the hypervisor layer. So it has virtual, okay? Okay, cool. So when we are, okay, let me first open chapter 5, PowerPoint. And also I would like you guys to go to page number 165, 165.
Figure.
I'm not at the, it'll be close to figure 5.1. Very like 2-3 pages before that. Right at the beginning of chapter 5, where we have overview. In the overview section on page 165, you will see these 2 words in bold, or two sets of abbreviations, SQL and DDS. Okay. If you're taking Intro to Programming and Database, you will be working with SQL to some extent in that course, probably somewhere at the end of November or somewhere in November. And we will also be in this course going into SQL around that time. But our main focus will be DDS because DDS is a big deal in the IBM world. DDS is how we have been storing things from 1960s. And this is before databases were even around. Databases came around in 1980s. And the white papers about databases, we started writing them around 1969, early 1970. And then we were doing a lot of research and databases started showing up in late 70s, early 80s. So we were still storing data prior to that in DDS. Okay, a lot of the companies still have vast amount of data in DDS. So if you are in the IBM world and you don't know DDS, you don't know much. So it's so important to learn about DDS. What in the world is DDS? DDS is the old way of storing data in files versus tables. Okay, so DDS is a file. And what do we mean by file in the IBM I operating system? Somewhere you can store data. That's called file. Otherwise, the meaning of file, as in Windows, doesn't apply here. So DDS is data description specifications. That means you create a file and you tell in that file what my record will look like. How many fields I have, what will be the data type of each field, what will be the size of each field, and then you create the file. Once the file gets created, then you can start storing data in it. Okay. Have you ever seen an Excel spreadsheet or any kind of spreadsheet, right? It has columns, columns has headings, right? By default, the data type is string or text, but you can go in a certain column and say, okay, in this column, everything will be stored as numbers. In this column, everything will be stored as dates, and so on and so forth. So basically what you do in a given spreadsheet, you define your column structure. That what kind of information will go in each column. And the collection of column structure makes a record. So in a data description specifications, you're pretty much creating your column structure. Okay, now if you have a driver's license or a state ID, does your state ID looks any different than your mom or dad or brother or sister or anybody? No, not really, except for the values are different, right? The fields are same. So when you are creating a specification document, you're coming up with what fields do I need to define this object? Okay, so for example, if I want to store data about phones, what do I need to store about phones? So I need to store their make, model, I want to store their price, specification, whatever specifications, that will define my entire data description specification document. Once I create that, then it's just a data entry like Excel spreadsheet. Does that make sense to you guys? Okay, so our main focus today is to learn to create the specifications document. In order to make that happen, we have to learn about two very important things, which you already know from programming. Number one, the name of the field. Number two, the data type of the field. Anybody who has done any programming understand what is a data type. Would anybody like to define the word data type? What is a data type?
It's a way that data can be stored.
Very good. That's all it is. It's just the type of data you want to store in that variable. The main difference is the variable will hold the data only for the run of the program, and field will hold the data forever until you delete it because it's physical storage. It's not a temporary storage in the RAM, unlike variable. So you're permanently storing the data here. Field names cannot be more than 10 characters. Same rule applies. That's a rule across the board. Nothing can be more than 10 characters long. Okay. Is everybody okay with that idea so far? Okay.
Yep.
SQL is a language which is designed to talk to databases. DDS doesn't understand SQL. Okay. SQL came much after, and it's specially designed to talk to databases. Unlike Windows, IBM operating system comes bundled with a database called DB2 for IBM I. What makes it so unique? What makes it so unique is that DB2 is part of the operating system. It's not a separate software. It's a component of the operating system. You cannot separate or uninstall it. Okay? It's pretty much like on a Windows operating system, you're trying to uninstall the control panel. You can't, because that's where it keeps all the information. That's exactly what DB2 is for the IBM I. That's where the operating system keeps all its information. It literally stores the information about the things that it collects in a database, which is written in DB2. That's why a lot of the corporations run DB2. because you cannot match the performance of DB2 because all other databases are installed on top of the operating system, and this one resides inside the operating system. So it always runs faster. So we will be learning about this database also, but in November, okay, towards the end. Okay, now let's walk into the chapter. In order for you to work with these DDS files, they have to be first created, and then they can be used by anybody, including programs, including apps, whatever. That's why they are called externally described files. They're external. Versus program defined described files, which are described through the program. Now, how do you code them? We code them in a utility called SEU. Does anybody remember seeing anything about SEU today?
It's not a TV show, is it?
No, in my class.
Something about source.
Very good. That was in
Well,
chapter.
here it says source entry utility.
There you go.
Very good. Very good. Does anybody remember chapter 2 or 3? It was chapter 2, page 45, table 2.1.
Screen design aid utility.
Page 45, table 2.1, second last line. STR, SEU. That's how you start the utility, SEU. And SEU stands for Source Entry Utility. The name itself tells you that it is meant to write the source code. Okay, that's where you put your source. And then once you're done putting in your source code, what do you guys typically do in your intro to programming class? After you put in your source code, what do you do with that source code?
Compile it.
Compile it, right? Before you run it, you need to compile it. So SEU cannot compile. SEU can only write the code. So where do we go to compile it? PDM. Programming Development Manager. It's not on page 45. I have to go back to chapter 5. Okay. On page number 165, which is right at the beginning of chapter 5, the very first page, it also talks about what is PDM, Programming Development Manager. And SEU is Source Entry Utilities, right on the very first page of chapter 5 under Overview. So where do you write your source code? Which utility?
SEU.
And which utility you compile?
PDM.
PDM, okay. You do not have to do it in two separate utilities on Visual Studio. Why? Samantha will be like, I'm not taking that course. No?
Because it compiles in Visual Studio, but it doesn't in IBM.
No.
Because on Visual Studio, you could debug it.
Yeah, but why? What do you call such a software that can do it all for you? You can compile in it, you can code in it, you can debug in it, you can run in it. What do you call it?
Compiler?
No, compiler only compiles. Compiler is a program that converts your source code into machine code. But what do you call that? Is that such a software which can do all of these operations for you in one place, as opposed to going to one application to write the code, another application to compile the code, another application to run the code, as opposed to running between applications, you do it all in one place. Such things are called,
In IDE.
very good, IDE. What does that stands for?
Forget what the I stands for, but the DE stands for development platform.
Integrated.
Platform
Integrated development environment.
Environment.
environment. Okay, cool. I'm like, when does the platform starts with the letter E?
I had a brain fart.
It's okay. Okay, so IDE, integrated development environment. That means it's one environment in which everything is integrated in one place. So you could code, compile, debug, run, whatever you want to do. You can do it all in one place. Okay, we have such an environment for green screen also, but it's not in green screen. You have to go outside of the green screen. And that is an environment I'll teach you in like 2 weeks. It's called RDI, Rational Developer for I. That's the IDE-like environment, unlike green screen environment, where everything has to happen in different utilities. Okay. So DDS is used to describe a simple physical file. So physical file is a placeholder for data. So anytime you hear the word physical file, it pretty much means a place where you can store data. That's it. Simple as that. So DDS is the top level categorization, and physical file is a lower level categorization, because DDS could be of different types. Okay. Now, when you write a source code, these are concepts I'm giving you, okay? When you write a source code, it's basically called data file member. The source code is called data file member. And that's on the slide that you're looking at, slide number 3. Data file member is not an object. It's a member. This member has to be placed inside an object called source physical file. You must be wondering why I'm going so slow. The reason I'm going so slow is because I want these concepts to sink in, because you have to know this, because you will be doing this every week now for the next 2 months. You cannot just start writing a member. The member has to be in a source physical file. Now comes another question. Can I put multiple members in the same source physical file? Yes. You could create one source physical file today and never create any other in 2 years. That's fine. You just keep adding your members to the same source physical file. Perfectly okay. But you need to create one to be able to create a member. Okay? So you first create a source physical file, and then you add a member to it. When you add a member to it, you then tell it the member level what kind of member it is. It's a physical file member, a logical file member, display file member, print file member. What is the nature of that member? Why do you need to do that? The next step is when you compile it, after the compilation goes through, it creates an object. So when it creates an object, it needs to know what was the purpose of the member. If it was created with a physical file intention, the object will be physical file object. If it was created with a print file intention, it will be a print file object. Okay, so members are compiled. Upon successful compilation, what do you get out of it? An object. Okay, an object, so that you can interact with it. You can store data in it. You can retrieve data from it. You can delete data in it. You can update data in it. And that's why this is an important step to know. Source physical file is placed inside a library like any other object. So you must have a library. Do you all have a library? Yes, you all do. Everybody has a library. The library is named after your current, your ID. Whatever your IBM ID is, that's your current library. That's where we can create our source physical file, and we can start adding members to that source physical file. Okay. All files in the IBM I operating system are classified as object type file. Anytime you create any of these items, it will automatically be categorized as file because they are there to store data in them. Okay, there are more than 90 different types of objects in the IBM iOS, and file is one of them. And it then have subtypes like physical file, logical file, print file, display file. Those are subtypes of file. Okay. So this is what I was talking about. Print file, format output from programs or utilities to create spooled print files in output queues. Display files, similar to print files in function, but they format data going to or coming from display screen rather than printer. And then you have the physical files, which are what will be learning as the first thing today, which allows us to hold and organize the user data. And then finally, the logical file, which is on page number 6, which talks about borrowing data from one or more physical files, which we will explore in next 2-3 weeks. Why do you want to borrow? Let me give you an example. Let's say you create a master file with customer information. And next day, somebody from sales comes and say, I want customer name, email, and their average income per household. You will not going to hand over the master file to them. You will just grab these 3 fields, put it in a logical file, and you'll hand over the logical file so that they can only query these 3 fields, because you do not want them to query the customer social security number or any of the other sensitive information. So logical files can be a great way for you to only open a little window into the actual file and give that over. Or if somebody comes in and said, okay, you know what? John will now take care of all the Wisconsin clients. So you create a logical file, and that logical file can only look at the Wisconsin clients. Now, if one of your clients decide to move from Wisconsin to Illinois and you update that in the master file, next time anybody runs a logical file, the logical file will not include that guy who moved to Illinois from Wisconsin, because logical file never holds the data. It always borrows in real time. So you don't have to worry about updating multiple files. So logical files will going to come handy when we get to that. Okay. Okay. So we learned about that you have to have library. Library will have source physical file. Source physical file will have a member. The member has a type, which could be one of the 4 types: print file, display file, physical file, logical file. You'll be learning only about the physical files and the logical files in this course. When you compile the physical file or a logical file member, upon successful completion, it creates an object to which then you can interact with. Wow, a lot of details, right? So these 2-3 slides will give you the basic information, and then once you create these objects, you can use high-level languages like COBOL and RPG to communicate with the data. So SQL is a standardized database language that is used extensively not only in the IBM iOS, but all viable platforms. SQL's wide support means SQL-based applications are highly portable, which provides a significant incentive for learning SQL. Once you learn SQL, the SQL is the same in SQL Server, DB2, Oracle, you name it. They're very similar. It's just a language which has very common tenets. DDS is a focus on its main focus of this chapter and the next chapter and a couple chapters after that is pretty much about storing data in files, which could be of logical or physical file nature, which would be considered database files or display files and printer files. there's a much enhanced environment called RDP, Rational Developer for Power, which we will be starting to look at in the next successful weeks, probably after 2-3 weeks. Okay. So how do you start the compilation environment? You type strpdm, and that's how you get to the compilation environment, and you can go from there. Let's take a break here, guys. Let's take a break here till 7:35. And then when we come back from the break, we will log into V2 Cloud, and we'll start to look at some of the things as we are going over stuff. So when you come back from the break, log into V2 Cloud, log into green screen, and I'm going to go from there. So I am pausing the recording for now. Please remind me if I forget to start the recording again. So as soon as I am logged in, I will share my screen. So this is the screen where you log in with your Blackboard credentials. So once we are in this environment, we will then click on ACS, which is Access Client Solutions. Before you click on 5250 emulator, what is that one thing that you should check first?
Your
What
connected to
system
the
you're on?
system.
Yeah.
Very
That's
good.
R.
Exactly. So the system should be Death Star, shouldn't say select a system. Okay. And then you click on 5250 emulator. This is the sign-on screen. After the sign-on screen, this is your initial program. And then when you hit enter, then that's your main menu.
A little behind you, my thing was given a little issue to get in.
Yeah, that's fine. I mean, when
Which one you say to hit again? Access ACS.
yeah, it's this the whole same process that we have been following for the last 2 weeks. Access Client Solutions, and then you make sure that you have Death Star in the system drop-down box already selected. Then you click on 5250 emulator, and then you sign on.
Okay.
If you can all please notify me when you're signed in. And the green screen. Uh, green check stays a little bit longer than thumbs up. So if you gave me a thumbs up, then can you please do green check? Thank you, sir.
I don't know why mine is not letting me in. I'm hitting the 5250.
Okay. Can you share your screen, Desmond? Let's have a look at it.
Give me 1 second. In the screen sharing thing again.
There's a green button at the bottom with an arrow going upwards called share screen.
Yeah, I'm looking for that. I got like 40 screens up right now. So.
It should be because I stopped sharing. It should be where your gallery is. Maybe you have to where next to the end button or leave button. There's a whole. I think it's an auto hide. Maybe I don't know. Depending on what version you're using, I think it's.
I don't know. Last time it was on my home screen. Sorry, guys.
No. It's all part of the learning process. Don't worry.
I don't know. I can't find it.
If you hover over the
Oh,
bottom,
I think I got it.
you got it. Okay.
You see that?
It's loading. Okay, now I can see. Okay. In the top left corner, under the welcome, you see system : No, not that far. Yeah, that's what. Click GTC. Yep, Death Star. Choose that. Now click on 5250 emulator.
Okay, that's what I was doing wrong.
Yep.
All right, got you.
No problem.
Let me get out of here.
You're out.
Okay.
So, Jared, Jacob, Maricela, are you guys still in the process? Okay.
Oh, I've been in.
I just signed in right now.
Okay, cool. Awesome. So I believe everybody is in. We're just waiting for Desmond to give us the go.
I'm a go, I think.
Okay. I want to be sure so that, you know, we are working.
Yeah. So I'm just logging in my username now.
Okay. Yeah. When you are in on the main menu, let me know.
Okay. After you punch in your password, just hit enter, right?
See that again?
After you punch in your password, you just hit enter and it should take you in, right?
Right. If you enter your IBM username and password, and then it will ask you to enter it again on the green screen. And then when you enter it, it should take you right to your initial program, and pressing enter will take you right to your initial menu.
It just brought me back to my ID. I mean, my username. It's not letting me jump.
Okay. How about you share again? I should have waited for you to log in all the way through. So go ahead, share your screen again, and maybe I can help you out with that process as well. Okay, now hit tab. Oh, okay, it is ITPA, is it 585? It's not S85. I think you wrote S85.
Okay.
I don't know, is it 585 for you?
Yeah, it's 585.
Yeah, yeah. Okay, now hit tab. And hit, like, put your password in. See, it is telling you even at the bottom that the username that you typed in doesn't exist because of the S.
Oh, okay.
Go ahead, complete your password. And then, oops, press the control key on the keyboard to get the control back. Okay, cool. Okay, cool. Hit enter again. Here we go. Awesome. I will share my screen now. And here we are, all of us. Okay.
My apologies.
No, don't worry about it. You know, you're stuck here today. Maybe somebody else will be stuck on a different screen. So that's okay, you know. It's all part of learning. Okay, so guys, before we went on break, we were talking about strpdm. strpdm is a utility that lets you access your libraries, your objects, and your members. So when you hit strpdm on the green screen, go ahead, type this command, strpdm, and hit enter. strpdm and hit enter. Okay. Now you see that you can work with libraries, work with objects, work with members. Those are the only three options that you have. How can I tell that this is not a menu, even though it looks like a menu?
No header.
Exactly. Doesn't have an ID in the header. It has a header, but doesn't have an ID in the header. It doesn't have the system name in the header on the right-hand side. So it is definitely a utility. It is not a menu. Okay. Now, what the PowerPoint tells you next is, instead of coming all the way to strpdm and then making a choice to work with libraries, if you want to directly go and work with libraries, you can also type this command, work library PDM. Okay, now let's first go to the libraries. Press number 1, push number 1, and hit enter. It will ask you, do you want to work with your library list? Say yes, enter, hit enter. Okay, and it will give you your library list. Okay, now this library list is not the same as you type in display library list, because look at the top header. Right now, the screen looks similar, but right now you are working with libraries using PDM. So it looks like a very similar screen, but it is part of a software called PDM. Okay, now let's F3 out of here. F3, go all the way back to the main menu. When you are on the main menu, type this command on the prompt, wrklibpdm, wrklibpdm, and hit enter. And notice it takes you directly to that screen that you were in after 2 clicks or 2 entries or whatever.
What did you want? Can you repeat what you want us to type?
This command from the PowerPoint, slide 17, first bullet point, work library PDM, wrklibpdm on the command prompt, and hit enter. Okay, then you can F3 out of there, back to the main menu. Then try the second command, work object PDM, wrk-obj PDM, wrk-obj PDM. When you hit enter, it takes you to your current library. You probably may not have any objects in there, but how can I tell I'm in the current library? Look at the library name at the top. My library, that's my current library, Yusuf S. Okay, so right now I'm looking at all the objects that I own. Now let me have 3 out of here. Let's try the third command. Work MBR PDM. Work MBR PDM. And that takes me to my members in which library? In my current library. How can I tell that? Because that's the name of my library. For you guys, it may be a little bit different. Because I've used this so many times, it is giving me a slightly different interface. But you guys don't even have any members right now. So that's why yours looks very different. But soon you will see that yours look similar to where I end up. Okay, now let me point out one more thing for you guys. Before we went on break, we talked about this. What did we talk about? That where are the members placed? Does anybody remembers where do we place the members?
Physical file.
In a source physical file, right? So I was in slide 17. Let me go back up to slide number 3. You create a source physical file, and then you enter the specifications for a member using a software called SU. Okay, now I'm going back to slide number 17. Okay, so this is the name of my source physical file, CLSP22SY. That's the name of my source physical file. And all these members that you see over here, they're inside that source physical file. So you probably, again, as I said, you don't have the same look and feel that I do because I've used this in the past. So it just took me directly to my last source physical file inside my current library where all my members are listed.
Real quick,
Yeah.
because when I hit it in, it said specify file name. I'm supposed to get that, right?
Yeah. That's what I said. You know, you will not have the same screen as I do because you don't have any members yet. So yes. Now, as I told you, that PDM is where you do what with the members? Does anybody remember what's PDM used for?
File.
Compiling. Very good. Okay. Now, can you identify any compile option on my screen?
Print.
14.
14. 14 is the compile option. Okay. Now, remember, this is a list screen. So if I want to compile any of these members, I go next to that member and I type 14 and I hit enter and it submits it for compilation. Okay. I'm not doing that right now, but just to tell you that that's how you would end up compiling. So today, when we create our first member together, we will come to the PDM. We'll come as far as a screen like this, and we will push option 14. And option port 14, when you do that, it will tell you that the following member has been submitted to the batch. Okay, just because it's submitted to the batch does not mean it is error-free. Just remember that. Okay, sometimes people compile and they are like, oh, the object is created, and they start using it. And then when they start using it, they start getting errors that the object not found because the object never got created. So I will teach you one more step to look for to make sure that your object is created before you can start using it. Okay. Now let me have 3 out of here. Okay. So work with libraries, work with objects, work with members. Those are the three things. Okay. Creating a member using SEU. Can you guys directly go to SEU and start creating members right now?
No,
Why not?
because we don't have any members.
No, I mean, start creating members. You know, like you start creating your first member.
We don't have a physical file.
You don't have what kind of physical file? There are two kinds of physical files.
Source.
Very good. Source physical file, because physical file, if you stop there, physical file is actually a member converted to an object, creates a physical file. So the correct word would be source physical file. Okay. So you cannot create a member until you have a source physical file. Okay. Now let's learn a little bit about this SEU editor. When you are inside an SEU editor, you have to enter some line commands to be able to work with the SEU editor. For example, in this PowerPoint, let me point out a few details to you so that you can understand what I'm talking about. Do you see all the lines have line numbers? Right? If you press F1, it is capable of opening a help right there and then for you. It is completely text-based. Okay, now let me go to another picture here. Look at this guy. This is a complete member. It has a lot of information. Okay, I am zooming in, expanding it, whatever, you know, because I want to tell you a lot of things about this guy. Can everybody see this? Is it large enough? Okay. Now, I want you to pay attention to these dots that you see, in which you see the A and some dots and then T dot name, right in the same line where you see FMTPF, right? These dots that you see over here are called column numbers. Okay. You know what? Let me do this. Oops. Okay. And now let me use maybe a pen or maybe a highlighter. Okay. So each one of these guys that I am putting in yellow color, those are columns. There are 80 columns in every line. And, okay, how many columns? 80, 80. Everything has to go in respective columns. Oops, discard. Okay, let me go back and maybe unshrunk the size because I want to use Shift F5 to show you this in here. Okay, so let me go back to highlighter. Highlight. Okay, so I told you that this area is where all your columns are. How many columns? 80. 80. Okay, and you have to be very careful that only certain set of information can go in certain columns. You cannot start writing from column 1. So how will I know where goes what? So what is it that you see on my screen right now towards the bottom? Who could be of help to you when you don't know where to put what?
F1.
F4.
4.
On each and every line, you will press F4. That will open up another window for you. You type in that window and fill in the blanks. When you're done typing and you press enter, things will automatically go in the correct columns. You wouldn't have to worry about it. This is the biggest mistake students make when they are trying to catch up with me, or when they are trying to do their homework outside of the class because they're so used to of text editors. They see a text editor and they start typing. Okay, because this is column specific. If you see, all the fields They are all in the same column. Okay, all the letters that you see over here, by the way, these are the data types. All the data types are in the same column. All the numbers are right aligned. All the precisions are also right aligned. You have 2 boxes for precision. That's why you see a little space over here to the left of 5 or to the left of 2. That's for a second digit of precision. Okay. And then here's a special area called functions where you can push extra functions if you want any functions to be applied to that particular field. And these are the names of the fields, like variables, field names. Okay, now, as I told you before, that all the fields go in a structure. That structure is called record format that you see on the very first line. This R followed by test TR, that's the name of your record format. So the first line will always have your record format name. You cannot start putting in fields right away. Okay, to sum up all of this information, you start with a library. In the library, you have your source physical file. Inside the source physical file, you create a member using SEU. You land inside an SEU file member. What is it that you type on the first line? What goes in the very first line? Record format. Okay, what does it go? Record format. Record format do not has a size, do not has a data type. You just write R and some kind of a 10-letter name to represent this record structure. It is a requirement. Then what you do starting from the second line, you start listing your fields, where the actual data will go. Each field will have a size and a data type. Forget about what this S means, F means, B means. We're not concerned about that right now. But each field has a name, a length, and a type. Then you may be like, okay, why isn't any number next to LTZ? Because they're fixed size. Fixed size. You don't have a choice of choosing length. And again, we'll look into all of that detail. Just hold on, okay? Okay, how will I know what kind of member am I creating? Is there a way to know what kind of member I'm creating? Check this guy out. PF, that means this is a physical file member. Everybody see this circle that I drew here? Okay. Once I'm done, how do I exit out of here?
F3.
Okay. When I exit out of here, it will ask me, do you want to save changes? That's the point you say yes. If you do not say yes, all your work will be gone. Just like any other file, right? Any other document that you are doing. If you don't save the changes, it's gone. Any questions?
Yeah, I actually have one question. What exactly is a precision?
Again, do not go into the details of data types. We'll talk about that. I'm just talking about from the standpoint of the bird's eye view as to what is a member, what is a record structure, what is a field. Those are the kind of things that we're concerned about right now. We will look into each specific type as our next step. So which function key will you press on each line?
F4.
F4. Just always remember that, okay? Now, if somebody made a mistake on any of the lines and they want to revisit, it's also possible for you to simply click on that line with your mouse and then press F4, make the changes in that window that will pop up on your screen and hit enter. Upon hitting enter, the changes will be reflected. So never in the beginning, try to avoid making the changes on the line if you make a mistake. Always go through the F4 route so that you do not mess up the column heading settings. Because if the columns go here and there, your file will never compile. Okay? Is everybody okay with this?
Yeah, so far.
So
So
far,
what's the reason why it's like it's in a certain column right there? Why isn't it in column 1?
that's how it is. That's how they created it, because they have other things to go in other places. So they specifically designed columns for certain things. Think about it. This is 1960s. Okay, this is not 2022. So that's why they design things to go insert. Do you know that when I started programming, indentation was not allowed in some languages?
Ew.
Even now, Python doesn't allow you to indent the code anytime you like. If you indent the code in Python, it means that this is a nested statement in the statement above. So indentation itself was a big breakthrough when people were about to use, I remember some languages that I learned that even you cannot give more than one white space. It was white space sensitive. That's how picky the compilers were. So, and this predates that era. Okay, so that's why things are very different here. Okay, any other question? I know it's probably a little bit stricter for you guys as you are not familiar, you don't want to code in strict environments like this one, but that's how it is for now, okay? Now, let me tell you a few other things before we go forward. Fields have names, you already saw that. And those names can be up to 10 characters long. The first letter in the name of the field must be an alphabet, uppercase, lowercase, whatever, or one of the special characters. But numbers are not allowed in the first placeholder. Okay, now you guys are doing intro to programming. Can you put in the first placeholder a number for a variable name?
No.
No, you can't. Okay. Usually the programming languages our databases will not allow you to have a number in the first placeholder. It's always a letter. So it could be a letter or any of the special characters listed here, but no numbers. But after the first place, you could use characters, numbers, and underscore. Blanks are not allowed. You cannot have a space in the name, just like you cannot have a space in the name of the variable. Length is the number of characters or digits in the field. So if it's a character field and I say 10, that means I'm allowing for maximum of 10 letter data. For numbers, it's X number of digits I'm allowing, okay? Now, you saw those funny letters in this column over here, S, P, F, B, H, L, T, Z. What they mean is listed over here on this slide. And I'll also tell you the page number in your book, because this is a very important page, because again, you would have to refer back to this page several times in the next 2 months. Page 192, table 5.2. Page 192, table 5.2. Okay, everybody get to see that? Okay. So when IBM originally came out with the data types, we had zoned decimal data type. Zoned decimal data type allows you to store numbers with decimal places. However, it would take more space. It would occupy the entire byte to store a number. IBM is the only operating system that I know of that divides a byte into half bytes. Usually, if you go to programming languages like C#, it will say that I will store a number in a full byte. 2 bytes, 4 bytes, 6 bytes, 8 bytes, or character takes a whole byte. But IBM decides to save space by dividing a byte into 2 half bytes. And each half of the byte will store data in it. That's what they call packed decimal data type. Does anybody over here knows what is 1/2 of a byte called? It's a fun,
Microbyte?
say again?
Microbyte?
No. It's a very funny word. I won't even say it. I will just type it. Okay.
Nibble.
Well, at least they know they thought they were funny in the 60s.
Nibble twice and get fight.
So 1/2 a byte is what it uses to be called packed. Then the binary stores digits. So does binary character stores characters, so single characters. Floating points, but range of floating points, short or long, is much smaller than packed in decimal. As you can see, they only support 9 or 17 digits. And then you have a character data, which is A. Anytime you see an A, it is character. Okay. If you do not put any data type for a field, it defaults to character. Okay. Hexadecimal is H. Date is L. Time is T. And timestamp goes into microseconds, so that's Z. Okay.
How would it tell the difference between floating point short and long when they're both F?
Well, then you will be able to put the number of digits and it will be able to figure out if it's a long or a short based on the length.
Is that what the precision column is?
No. Precision is something else. I'll talk about precision next. What precision means is how many decimal places are supported. So if it says 9F5, that means out of 9 digits, 5 are decimal. How many digits are remaining? 4. So your whole number part can have 4 digits, decimal, followed by 5 numbers. So your precision is how far you can go in decimal points. 4B2 means total 4 digits. Out of the 4 digits, 2 are decimal and 2 are whole numbers. 9B, no precision, means all 9 digits are to be used for storing numbers, whole numbers. Does that make sense? Does that answer your question about precision? Okay.
Yeah, thank you.
No problem. Okay. So page number 193, 194, 195, these 3 pages talk about data types that I will that's why, it's very important for you to read the chapter during the week. Okay? It's very important for you to do that. Okay. Now let's go to chapter 6. So I'm closing this. Don't save any changes. I'm going back to unit 4 and I'm opening chapter 6 PowerPoint. And chapter 6 in the book starts from page number 213, by the way, 213. It's a continuation of the previous chapter. So it says creating and using an externally described database file. So it pretty much talks about working with the physical files. Again, the chapter starts out by telling you that you need SEU to code your member and you need PDM to compile your member that you already learned in the previous chapter. Then once you are done creating an object, you need a data file utility to add data to it, DFU. Okay, so now you know about 3 utilities, SEU, PDM, and DFU. Okay. Use SU line commands, that's one objective. Use PDM options, that's another objective. Use CL commands or PDM to display object and enter data. Those are the 4 main topics here. SU is a general purpose full screen editor that lets you enter or change the source statement that will be used to create an externally described file or even write programs in high-level languages. In addition to using SU to create or edit a source member, you can use it to display or print an existing member of a source physical file. What does that mean? That means if you already have created a member in a source physical file, you can actually use SU to just look at that existing member. Now, here comes a question. If I create a source physical file and I put a member in there and I write a source code in the member, and then I compile the member, and then somebody comes back to me and say, you know what, you forgot to add a field. It needs 1 additional field. So I go back into the SU and I add a field and save the changes. Is that enough? Let me repeat so that you can hear it again. I created a member using SCU. I saved the changes. I compiled. Once I was done compiling, successfully created an object. Somebody told me that I missed a field, so I went back in the SCU in the same member. I added one additional field. I saved the changes. Will that update the object?
Don't you have to recompile it then?
Very good. Okay. And when you recompile an object, if you had entered any data in it, it will be all lost. So that's one thing you have to be careful about. If you are recompiling an existing object, it will give you a warning that the object already exists. Would you like to proceed with it? When you say yes, it will recreate the object for you, but the data will be lost. Okay.
Isn't what, like when you're saving it though, that would save it?
You are only saving the description, not the data. Okay, and you have made the changes to description. And now when you have changed the description and you recompile, each compilation produces a brand new object. If the object already exists and you say yes, it will overwrite it completely. So once it overwrites it, it's a clean sheet.
So how do you stop that from happening?
You can't. So what is the way around is people usually make a copy of the object, then rewrite the original, then copy the data from one object to another.
Oh, man, okay.
Okay. Okay. How do you create a source physical file? This is the command. CRT src pf. Create source physical file. Okay. Type this command on your green screen prompt. CRT src pf. Do not hit enter. Just type the command. Then press F4. So CRT src pf. Press F4. Okay. You know what I usually do? I ask people that let's come up with some kind of a name that will have some commonalities. And I usually write that name down on a sticky note and put it somewhere on my computer because we will be using the source physical file every week. Okay. So we usually come up with some kind of a mechanism. You can also do the same. Okay. So this is fall semester, right? So FA 22, fall 22, your initials, and then a number 1. Okay. So FA 22, your initials, and a number 1. So if any one of us forget, it is so easy to remind that FA 22, your initials 1. So I usually put this a sticky note on my computer, and I'll probably throw it away in December. Okay. With me, everybody? Okay.
Can you go back a little bit?
How much back?
How
did I get here?
No, I know that you did the create like
Source
this
physical
here,
file?
yeah.
Yeah.
But how did do I go to the prompt screen first?
Yeah, once you are on the command line, anywhere you can see a command line, you just type CRT srcpf
Oh,
and hit
okay.
F4 and hit F4. And then you will land on this page. Did you find it?
Hold on.
Okay.
Sorry.
No, that's fine. That's fine. I'm glad you spoke because otherwise some people wait till I'm done and they will be telling me at 9:05. By the way, I was lost at 8:20. Okay.
It says command in library not found.
Okay, Samantha, are you able to share your screen?
Yes.
Okay, let me stop sharing and I will let you share. Oops. Okay, mine is acting up. It did act it up yesterday too, and it ended up closing my whole Zoom. Come on, don't do that. My Zoom is stuck.